Okay, we're going to expand and simplify using two methods. So the first method will be Pascal's triangle, and then the second one will be binomial theorem. Okay, so we have Pascal's triangle. So remember, row 0 is first. If you do not label it row 0 and you label it row 1, your answer will be, it won't be correct. Okay, you have to remember that it's row 0 comes first. Then row 1, row 2, row 3, and lastly we're going to go to row 4. And we're going to read row 4 because the exponent here, if you guys can see it, it's 4. Okay, so the order or the degree is 4, so we're going to go to row 4 on our Pascal's triangle. Okay, so what we're going to do, once you have the rows out, you're going to write out the numbers. Okay, so we're going to write them out 1, 4, 6, 4, and 1. I'm going to just put plus for all of them. Okay, it's always going to be plus. No negatives here. Okay, so then what we do is we take the first term in the bracket and we're going to put it beside each of the numbers. So our first term is x. Okay, so we're going to put an x next to all the numbers. So x, 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 and x. Then we're going to take the second term and do the exact same thing. So we're going to take the y and we're going to put the y next to the x. Okay, so first we put all the numbers based on the Pascal's triangle. Then we take the first term, put it next to each of those numbers, and then we take the second term and do the exact same. Okay, now, whenever you were to expand, so in the past, what you've done with this, you would write it out, so x plus y times x plus y times x plus y, and then x plus y. And then you would distribute. Once you get that answer, then distribute to the next one. When you get that answer, distribute to the last one, which takes a lot of work. Okay, so Pascal's triangle gives us a shortcut instead of it distributing multiple times, and then keep multiplying, and it's very, very easy to make a mistake. So we could do this in one step. Okay, so we have an exponent of 4. Okay, so what happens is for the first term that we have with the x, we're going to put an exponent of 4 to start. And then for the x's, we're going to count down. So we go 4, then we're going to go 3 on the next one, 2, 1, and then 0. Okay, count all the way to 0, just like the rows. We go from 4 to 0. Then we're going to do the same thing, but going the other way for the other term. So we start at 0, now we're going to go 4 again, then 3, 2, 1, and 0. Okay, so make sure you're in opposite directions when you count for each of the terms. And we're pretty much done, but we're just going to simplify it just to make it better. Anything to the power of 0 is 1, so we're just going to cross off the zeros. We do not need them anymore. And we don't need to write the ones, so I'm just going to cross off the ones here. So in the next line, we're just going to write whatever remains. So first term is x4, x to the power 4 plus, so again, just the ones here, so cross off these ones. 4x cubed, y, so 4x cubed, y, plus 6x squared y squared, 6x squared y squared, plus 4x y to the power 3, and lastly, we're just left with y to the power of 4. Okay, and then that is your final answer. So to go from this to our expanded form, it only takes 2 steps, which is much easier than actually expanding the long way. Okay, If you, I know I'm gonna get this question. If you did leave the ones, it's perfectly fine. So if you left your one in front of here, that's fine. If you left your one on the y and on the x and in front of this y, that is fine. There's nothing wrong with it. The most simplest form is not to write the ones, but if you had them there, that is fine. Okay, so that is expanding by using Pascal's triangle. Now we're going to do expanding using binomial theorem. So just going to write it out here. So NCR x n minus r y to the power of r. Most people at the start like Pascal's triangle more, just because they're more familiar with it. Okay, so this is actually a fairly easy way as well. Okay, so we have the power 4 here. So this is NCR. So just ignore this for now. So this is NCR, so just what we were doing. So the total, choose a certain amount, okay? So our total here is 4 because our exponent is 4. So we're gonna start with 4, and then what we're gonna do is choose different numbers. So we're gonna start with 0. So we're gonna do n, choose 0, then n, choose 1, n, choose 2, n, choose 3, and onwards. So here, we're gonna have 4, choose 0 as our first term, plus 4, choose 1, plus 4, choose 2, plus 4, choose 3, and lastly, 4, choose 4. Okay, 4, choose 1, 0, 4, choose 1, 4, choose 2, 4, choose 3, 4, choose 4. Okay, then we're going to put the first term beside each of them. Let's get a different color for this one. So x, 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 and x. Okay, and the top of the x, it tells you what to do. It tells you to take your n and subtract r. So it's easy. You have the numbers already there. So 4 minus 0 is 4. 4 minus 1 is 3. 4 minus 2 is 2. 4 minus 3 is 1. And 4 minus 4 is 0. So we get the same thing, 4, 3, 2, 1, 0, as we did previously. Then we take our second term, which is y. We're going to put y beside each of them, just like we did. Okay, and again, if you look at the formula, y, whatever the r is your exponent, whatever the r is. So here our r is 0, so 0, 1, 2, 3, and 4. Okay, and now we simplify it. Okay, so in your calculator, 4 choose 0 is 1. X to the power 4. We don't need our zeros. That's gone. Okay. Plus, in your calculator, 4 choose 1. You're going to get the answer of 4. X cubed. Y to the power 1. Don't need to write your ones. 4 choose 2. What was it? 6. X squared, y squared. Then 4 choose 3 is 4, x to the power 1, y cubed. And lastly, 4 choose 4 is 1. Cross off your x to zeros, that's just 1. And then y to the power 4. So you get the exact same answer. Just to make it a little bit nicer or more neater, take away the 1s, here, here, and here. And there you have expand and simplify using the binomial theorem. Okay, so we did Pascal's triangle and then the binomial theorem. Okay, the homework for that section, so let me grab it, I don't know if it's at the bottom of the page or not. So this is 3.4, page 126, numbers 1A, 2 to 4, 8 to 10, and 13. So essentially it's 8 questions. So 1A, 2, 3, 4, 8, 9, 10, and 13. There's a couple of the map ones that are a little bit tricky. Try your best, and obviously we could take them up during homework time, or in the next time you're in class, we could go through them and take them up with you. Okay, so that is the rest of 3.4. Take care.